Hello, my name is Nehemiah Shan, and this is my video for submission for EMI 210. This is the video of my experiment where I threw a basketball from a height and let it bounce once for the change in velocity and momentum. The experiment ended once the ball hit the wall. This is the ball used in the experiment. The ball is about 29.5 inches in diameter and it weighs about 594 grams or 0.594 kilograms. The distance the ball traveled before the first bounce was about 7.115 feet. The distance before hitting the wall was about 3.6975 feet from the first bounce. The total distance traveled was 10.8125 feet. These are the times that the ball was released, first hit the ground, and finally hit the wall. The time it took from the first position to the second position was about 0.81 seconds, and the time it took from the ground to the wall was about 0.79 seconds. With this information, along with the information about the distance, we can find the velocities at each position. It was found that the ball traveling from start to the ground was going at a speed of 8.78 feet per second, and the speed of the ground to the wall is 4.68 feet per second. The given information that we have for this problem is the ball has a diameter of 29.5 inches, the ball is 594 grams or 0.594 kilograms. The time it took to get from start to the ground was 0.81 seconds for 7.115 feet, and then from ground to the wall was 0.79 seconds for 3.6975 feet, and the total distance traveled was 10.8125 feet. The ball was first dropped from 6.792 feet in the air, and velocity from start to the ground was 8.78 feet per second, and from ground to the wall was 4.68 feet per second. What we can assume is that in this hypothetical there is no friction, neglecting the human in the experiment, the system is a particle, and g is equal to 32.2 feet per second squared. The problem that I would like to solve for this is finding the coefficient of restitution. The steps of solving this problem would be to first determine all of the kinds of velocities that we have in this experiment. In this instance, we only have a final of A and the initial of B. With this information, we can plug both of those numbers into the coefficient of restitution equation to find our answer.